Welcome to our deep dive into one of physics' most misunderstood concepts, entropy. At first glance, entropy might seem like a complicated term reserved for textbooks and scientists, but it's actually a fundamental idea that shapes our universe. In simple terms, entropy is a measure of disorder or randomness in a system. But why does this matter? Well, understanding entropy helps us make sense of everything from melting ice to the fate of the cosmos. Let's start by breaking down what entropy really means and why it's so crucial in physics. The concept of entropy was first introduced in the 19th century by Rudolf Clausius, a German physicist. He was trying to understand why some processes in nature seem to go in only one direction, like heat flowing from hot to cold. Clausius realized that there was a hidden quantity, which he called entropy, that always increased in natural processes. This discovery laid the foundation for the Second Law of Thermodynamics, one of the most important principles in physics. Let's explore how this law shapes our understanding of the world. Second Law of Thermodynamics states that the total entropy of an isolated system can never decrease over time. In other words, natural processes tend to move towards more disorder, not less. This is why you never see a broken cup spontaneously reassemble itself or heat flowing from a cold object to a hot one without outside help. The second law explains why time seems to move forward and why some changes are irreversible. It's a rule that governs everything from engines to the expansion of the universe. Entropy is often described as a measure of disorder. Imagine a tidy room where everything is in its place. Over time, without effort, things tend to get messier. That's entropy at work. In physics, this means that systems naturally evolve from order to disorder unless energy is put in to maintain order. This tendency is not just about rooms or objects, it applies to molecules, stars, and even galaxies. The universe itself is moving towards higher entropy, a state of greater disorder. You encounter entropy every day, even if you don't realize it. Think about an ice cube melting in a warm room. The orderly structure of the ice breaks down into the more disordered state of liquid water. Or consider a drop of ink spreading in a glass of water. The ink molecules move from a concentrated spot to a random distribution. These are classic examples of entropy increasing, showing how nature prefers disorder unless energy is used to maintain order. Let's look at cooking as an example. When you bake a cake, you start with separate ingredients: flour, sugar, eggs. Mixing and baking them increases the entropy because the ingredients become more randomly distributed and can't be easily separated again. The process is irreversible, just like many natural changes. This is entropy in action, transforming order into delicious disorder. Entropy is closely linked to the arrow of time. We remember the past as more ordered and the future as more disordered. This is because entropy tends to increase, giving time its direction. For example, you can scramble an egg, but you can't unscramble it. This one-way street is a direct result of the second law of thermodynamics and the relentless march of entropy. On a cosmic scale, entropy explains the fate of stars, galaxies, and even the universe itself. As stars burn their fuel, they increase the entropy of their surroundings. Over billions of years, the universe is moving towards a state of maximum entropy where everything is evenly spread out and no useful energy remains. This scenario is sometimes called the heat death of the universe, a state of ultimate disorder. Many people think entropy means chaos or destruction, but that's not quite right. Entropy is about the number of ways a system can be arranged, not just messiness. A shuffled deck of cards has higher entropy than a new one, but both are still decks of cards. Entropy doesn't mean things fall apart instantly, it's a measure of possibilities and probabilities. Entropy is deeply connected to probability. The more ways a system can be arranged, the higher its entropy. For example, there are many more ways for gas molecules to spread out in a room than to cluster in one corner. That's why gases fill their containers and why entropy tends to increase. It's all about what's most likely to happen. Entropy isn't just about physics, it also appears in information theory. In this context, entropy measures the uncertainty or unpredictability of information. The more random a message, the higher its entropy. This idea is crucial in fields like cryptography and data compression, where managing information entropy is key to security and efficiency. Living things seem to defy entropy by creating order, but they actually increase the entropy of their surroundings. For example, a plant uses sunlight to build complex molecules, but in the process it releases heat and increases the entropy of the environment. Life doesn't break the second law, it works within it, exporting disorder to survive and grow. Engines are classic examples of entropy in action. When fuel burns, it releases energy that can do work, but not all of it is useful. Some is lost as heat, increasing entropy. This is why no engine is 100% efficient. The second law of thermodynamics sets a fundamental limit on how much work we can extract from energy sources. Chemical reactions often involve changes in entropy. When two substances mix, their molecules become more randomly distributed, increasing entropy. Some reactions happen spontaneously because they increase entropy, while others require energy input to proceed. Understanding entropy helps chemists predict which reactions will occur naturally. Heat is closely tied to entropy. When heat flows from a hot object to a cold one, the overall entropy increases. This is why heat engines and refrigerators work the way they do. They move energy around, but always with some increase in entropy. The flow of heat is a one-way street dictated by the second law. Some processes in nature are reversible, but most are not. The reason lies in entropy. When entropy increases, it's almost impossible to reverse the process without adding energy. That's why you can't unmix cream from coffee or unburn a piece of paper. Entropy sets the direction for natural changes. Life is incredibly complex and ordered, but this order comes at a cost. Living organisms constantly use energy to maintain their structure and function, exporting entropy to their environment. This balance allows life to exist without violating the laws of thermodynamics. In fact, the struggle against entropy is what drives evolution and adaptation. Modern technology, from computers to power plants, must contend with entropy. Devices generate heat and lose energy as they operate, increasing entropy. Engineers work hard to minimize these losses, but the second law sets a hard limit. Understanding entropy helps us design more efficient machines and systems. Aging can be seen as an increase in entropy within living organisms. Over time, cells and tissues become more disordered, and it takes more energy to maintain order. While we can slow the process with healthy habits, entropy ensures that aging is inevitable. It's a natural consequence of the laws that govern our universe. Every time you cook, you're witnessing entropy in action. Chopping vegetables, mixing ingredients, and heating food all increase the randomness of the system. The delicious results are a testament to the creative side of entropy, where order is transformed into something new and flavorful. Environmental processes like weather and erosion are driven by entropy. The sun's energy creates order temporarily, but over time, wind, water, and heat increase the disorder of landscapes. Understanding entropy helps scientists predict changes in climate and ecosystems. The universe began in a state of low entropy, with matter and energy highly concentrated. Since then, entropy has been increasing, driving the expansion and evolution of the cosmos. The journey from order to disorder is written into the very fabric of space and time. Black holes are mysterious objects with incredibly high entropy. When matter falls into a black hole, its information is scrambled and the entropy of the black hole increases. This has led to fascinating debates among physicists about the nature of information and the ultimate fate of matter in the universe. In quantum physics, entropy plays a role in understanding the behavior of particles and information. Quantum systems can be in superpositions, but when measured, their entropy increases as possibilities collapse into outcomes. This connection between entropy and quantum measurement is a hot topic in modern physics. Looking ahead, entropy will continue to shape the fate of the universe. As stars burn out and galaxies drift apart, the cosmos will approach a state of maximum entropy. While this sounds bleak, it's a natural outcome of the laws that govern everything. Understanding entropy helps us appreciate the beauty and complexity of our universe. Human activities, from building cities to running factories, increase entropy. We use energy to create order, but in the process, we generate waste and heat, raising the entropy of our surroundings. This is why sustainability and efficiency are so important. They help us manage the inevitable increase in entropy. Artists sometimes use entropy as inspiration. Abstract paintings, for example, can represent the transition from order to chaos. The creative process itself often involves breaking down old ideas and rearranging them in new, unexpected ways, mirroring the increase in entropy seen in nature. Music can also illustrate entropy. A well-ordered melody can be transformed into a complex, unpredictable improvisation. As musicians experiment and add variations, the musical entropy increases, creating new and exciting sounds. This blend of order and disorder is at the heart of artistic expression. Language evolves over time, becoming more diverse and complex. Words change meaning, new phrases emerge, and old ones fade away. This process increases the entropy of language, making it richer and more expressive. Entropy helps explain why communication is always evolving. Our memories fade and change over time, a process that can be seen as an increase in entropy. Details become less clear, and events blend together. This natural forgetting is another example of how entropy shapes our lives, reminding us that nothing stays perfectly ordered forever. Even in economics, entropy plays a role. Markets tend to move from order to disorder, with prices fluctuating and trends changing unpredictably. Economists use concepts similar to entropy to model uncertainty and risk in financial systems. Creativity often involves breaking down old patterns and forming new ones. This process increases the entropy of ideas, making room for innovation and discovery. Whether in science, art, or daily life, embracing entropy can lead to unexpected breakthroughs. While entropy tends to increase, order can still emerge. Patterns form in snowflakes, crystals, and even galaxies. These pockets of order are temporary, maintained by energy flows. Eventually, entropy wins, but the beauty of order persists for a time. Sustainability is about managing entropy. By recycling materials, conserving energy, and reducing waste, we can slow the increase of disorder in our environment. While we can't stop entropy, we can make choices that help maintain order for future generations. Innovation thrives on entropy. New ideas often emerge from the breakdown of old systems and the mixing of different perspectives. By embracing change and uncertainty, we open the door to progress and discovery. Our bodies constantly fight entropy by repairing cells and maintaining order. Healthy habits like exercise, good nutrition, and rest help slow the increase of disorder. While we can't stop entropy, we can support our body's efforts to stay organized and functional. Learning is a process of organizing information, reducing uncertainty, and creating order in our minds. However, without practice, knowledge can fade and entropy increases. Continuous learning helps us maintain mental order and adapt to new challenges. Relationships require effort to maintain order and harmony. Without communication and care, misunderstandings and distance can increase, raising the entropy of the relationship. Investing time and energy helps keep connections strong and meaningful. Societies organize themselves through laws, traditions, and institutions. Over time, disorder can creep in through conflict, change, or neglect. Managing social entropy requires constant attention and adaptation to maintain stability and progress. The arts thrive on the interplay between order and disorder. Whether in painting, music, or literature, artists use entropy to challenge expectations and create new forms of expression. This dynamic tension is what makes art so powerful and engaging. Sports are full of unpredictable moments, from surprise victories to unexpected upsets. This unpredictability is a form of entropy, making games exciting and dynamic. Athletes and teams work to create order and strategy, but entropy ensures that anything can happen. Innovation often arises from the breakdown of old systems and the mixing of new ideas. Entropy creates the space for creativity and progress, allowing us to adapt and thrive in a changing world. Embracing uncertainty can lead to breakthroughs. Digital systems like computers and the internet must manage entropy to function reliably. Data can become corrupted and systems can fail without regular maintenance. Engineers use error correction and redundancy to keep digital entropy in check. Physicists continue to explore the mysteries of entropy, from black holes to quantum computers. New discoveries may change our understanding of disorder and information, opening up exciting possibilities for the future. Entropy remains at the heart of the most profound questions in science. In summary, entropy is much more than a scientific term. It's a principle that shapes every aspect of our lives and the universe. From the smallest atom to the largest galaxy, entropy guides the flow of energy, the direction of time, and the evolution of complexity. By understanding and embracing entropy, we gain a deeper appreciation for the beauty and unpredictability of the world around us.